Another way of looking at the mean value theorem is by looking at the slope through the formula of f prime of c equals f of b minus f of a over b minus a. If f can be both continuous and integrated, then you can find its average or mean value using the formula 1 over b minus a times the integral from a to b of f of x dx. The theorem states that y equals f of x is both continuous and differentiable, meaning there's no points of discontinuity and that the limit exists. Therefore, at least one point c must exist between the closed interval from a to b. So now that we've explained the mean value theorem, let's put it to work. For example, show that the function f of x equals x squared satisfies the hypotheses of the mean value theorem on the interval from 0 to 4. So for this problem, we're given a graph from 0 to 4, and we can see that it's both continuous and differentiable on the interval from 0 to 4. We know that the graph is both continuous and differentiable because at f of 0 equals 4 and at f of 4 equals 16. And you can find these values for y by plugging it into f of x equals x squared. After we've confirmed that f of x is continuous and differentiable, then we use the mean value theorem formula of f prime of c equals f of b minus f of a over b minus a, and since we're given that f of x equals x squared, we know that f prime of x equals 2x. So you plug that into the formula and you're left with 2c equals f of 4 minus f of 0 over 4 minus 0. Then you solve for c and you should come up with c equals 2. So to interpret all of this, the line that is tangent to f of x equals x squared at x equals 2 has a slope of 4 and is parallel to the points from a to b, which shows that our graph proves the mean value theorem. Once you have your graph, you can see that there's this curved line with two parallel lines. The first one is the secant line with two connecting points, and since there's no holes or any jumps or any points of discontinuity, then the theorem states that between this line there must be at least one point, let's say c, that is equal to this tangent line below it at that exact point, that it must exist.
Let's look at examples from the 2011 AP Free Response Form B questions. Question number 2 is asking, a 12,000 liter tank of water is filled to capacity. At time t equals 0, water begins to drain out of the tank at a rate modeled by R of t, measured in liters per hour, where R is given by the piecewise defined function. As you can see, the function is given below. The question is asking, A, is R continuous at t equals 5? Show the work that leads to your answer. And B, find the average rate of change which water is draining from the tank between t equals 0 and t equals 8 hours.
Because this question doesn't necessarily deal with the mean value theorem, we will disregard it for now. However, if you still want to do this problem, in order to test if R is continuous at t equals 5, you test the left hand and right hand limits of R of t by plugging in 5. This is a calculator question, so plug in 5 into the equations. If answers are equal to one another, R is continuous. By plugging in 5 into R of t, the left hand limit gives 375. The right hand gives 367.879. Therefore, R is not continuous. Here you are trying to find the average rate at which the water is draining. In order to do this, you're using the average value equation, which is 1 over b minus a times the integral of f of x dx from a to b. Because this is still a calculator question, you can plug the equation into the calculator. The intervals are already given to you in the problem, which is 0 and 8. Note that the bigger number is always b. Plug those numbers into the equation. Because you are given two equations, it is best that you separate the two integrals. One integral will go from 0 to 5, while the other is going from 5 to 8. Plug into your calculator using the Math 9, and you will get your answer. The AP test will take 258.052 or its rounded number 258.053.
Ben rides a unicycle back and forth along a straight east-west track. The twice differentiable function b models Ben's position on the track, measured in meters from the western end of the track at time t, measured in seconds from the start of the ride. The table above gives values for b of t and Ben's velocity b of t, measured in meters per second at selected times t. Question A is this. Use the data in the table to approximate Ben's acceleration at time t equals 5 seconds. Indicate units of measure. Part B. Using the correct units, interpret the meaning of the integral of the absolute value of v of t dt from 0 to 60. Approximate using a left Riemann sum with the intervals indicated by the data in the table.
The mean value theorem can also be used to give an approximation at a specific point. In this problem, we are asked to approximate Ben's acceleration at time t equals 5. Looking at the table, we are not given t equals 5. In order to solve for this equation, we will use v of b minus v of a divided by b minus a. We are already given the numbers, so we simply just plug and solve. For part B, when looking at the equation, you are saying that it is the total distance in meters that Ben rides in the 60-second interval. You basically want 3 intervals because you are using the left-hand Riemann sums. To do this, you take the value v of 0 and multiply that by the difference of 10 minus 0. You do this until you have 2.5 multiplied by the difference of 60 minus 40. All values are added together.